course called Applying Properties of Similar Triangles. Okay, so the first thing we're going to learn about is something called the triangle proportionality theorem. The triangle proportionality theorem. Triangle proportionality theorem. This word proportionality has the word what in it? Proportion, right? So we spent quite a bit of this chapter talking about proportions, setting up a proportion, solving proportions. How do you solve a proportion? Cross product, okay? So by now you've done lots and lots of them. So once you get that proportion set up, you should be able to do the cross product and then solve for that variable, okay? So the triangle proportionality theorem, basically you're going to have a triangle. We will call this triangle A, B, C. And that triangle is going to be cut by a line. And that line, we'll make it right here. We'll say that it intersects right here at E and intersects right here at F. That line is going to be parallel. You see how I'm putting the little carets on both the line intersecting and the side that's opposite it? Okay. It cuts the two sides of the triangle into a top piece and a bottom piece, a top piece and a bottom piece. And so if you have this triangle cut and it creates this proportion from it. So this theorem says that if the two lines are parallel, so EF is parallel to BC, okay, so if EF is double hockey stick to BC, that double hockey stick is the shortcut for parallel, right? Then you're going to be able to just set up a proportion from the four pieces. You see how there's 1, 2 on the left and 1, 2 on the right. You guys see that? Okay, which is great because your proportion has a left ratio and a right ratio, a top and a bottom, a top and a bottom. So you're going to look just exactly from the way it's set up, and you're going to fill in those four pieces, okay? So we're going to write the algebraic letters that are there, but normally there will be numbers in 3 of those places, right? And in one spot, the one you want to solve for, there'll be a what? An X or whatever variable, okay? So we'll do the top piece on the left, which is AE, the bottom piece on the left, which is EB, the top piece on the right, which is AF, and the bottom piece on the right, which is FC. Okay? Makes a nice proportion. Just keep it in the same order, on the same side, and in the same order, and then you won't get mixed up. All right? Just so happens that the converse of this theorem is also true. So, if AE to EB is equal to AF, over FC, then those two lines are going to be what? Double hockey stick. What does the double hockey stick mean? Parallel. Then the two lines are going to be parallel. So EF will be parallel to BC. Okay? So here's what problem with some numbers and some variables in it is going to look like. All right, so example number 1. You're going to have a triangle. I'm going to try and throw you off a little bit by drawing the triangle crooked. Okay? But you guys got this. We'll call this triangle RST. We're going to intersect it with a line right here. That line just so happens to be parallel. The intersections we'll call U and V. Okay? Now let me give you some measurements. We're going to have Now, it's crooked, right? So it's turned. So if you need to turn your paper, you can turn your paper, or just turn your head, right? So if I kind of like just split it down the middle this way, I have my left side, my numerator and denominator, and then I have my right side, my numerator and denominator, okay? So let's do the RV is going to be 10 meters. The VT is going to be 4 meters. The RU is going to be 14 meters. And US, we'll put an X there. You might see a question mark, or it might just say, find US, and it'll be blank. And then you just fill in the variable that you like, okay? Usually X, okay? So when I go to set up my proportion, I'm going to do a fraction equal to a fraction. And since I've kind of mentally cut it in half and go, okay, this is my left side, numerator, denominator, top, bottom. So I'm going to go 10 to 4. Okay, turn your head if you need to. And then I've got my right side, my right fraction, and I've got top to bottom, numerator to denominator. So 14 to X. Once you have your proportion set up, you're going to do your cross product, and then you're going to solve. Okay? I like my variable on the left, so I'm going to go this way first, but you can go the other way first if you would like. So 10 times X. Set it equal to 4 times 14. Pull your calculator out if you need to. You're going to have 10x on the left. 4 times 14 is 56. The inverse operation of multiplying by 10 is dividing by 10. And so I got the decimal 5.6 meters. Is it okay to get a decimal?
Yes.
Yes. Can you leave it as a fraction? Yes. Sure. Okay. Just reduce it. All right. Any questions on example number 1 there? Okay. After that theorem, you've got another theorem, and this theorem is called the transversal proportionality theorem. Okay, 2 transversals. How many transversals did we draw on this one? Just 1. So now we're going to draw 2. Okay, and we're not even necessarily going to have a triangle. You can have it with a triangle, or you can just have a bunch of lines intersecting. I don't know if you guys remember that from the transversal chapter last semester. Okay, so it's quite possible that you would just have some lines, and then you would have some more lines. You're just going to have kind of lines everywhere. Okay, so we're going to do 3 horizontal lines, 2 vertical lines. That creates a bunch of intersections. You see how many intersections it creates? 1, 2, 3 on the left, 1, 2, 3 intersections on the right. Okay, we're going to label them AB up top, CD in the middle, and EF down here. Okay. This theorem says that if you have some parallel parts, so if AB is parallel to CD, so here's AB, here's CD, so we're going to put a little caret on both of them, and CD is parallel to EF, so we're going to put another caret. So we end up having all 3 lines parallel. Then it's going to create another proportion, okay? And I have it turned, so it's facing me, but it could be sideways, okay? It's going to be the left side, which is segmented to a top and a bottom, creating a numerator and denominator, and then a right side proportioned to a top and a bottom, creating a numerator and a denominator. So we're going to say that AC over CE, and then on the right, the top portion becomes the numerator, which is BD, and the bottom portion becomes the denominator, which is DF. Okay? So it's pretty much the same as the triangle proportionality theorem, it's just not with a triangle. It's with just lines, okay? So let's look at one with just lines. And I'm going to draw it crooked so you can see it set at an angle. All right, so example number 2. All right, so example number 2 is going to use the two transversal proportionality theorem. Bless you. The only thing different than what we just wrote is that it's turned on its side. Okay, so instead of being straight up and down, it's turned crooked. So my little trick is I kind of do a dashed line. And I go, okay, so this is going to be my left side, and this is going to be my right side. And then I'm going to, well, obviously solve for x. I filled in the, solve for x, okay? I filled in an x for the one missing spot. All the other 3 spots have numbers. And so I'm going to draw my fraction equal to a fraction. So I need my left side on this side, my right side on this side. Don't try and move all this stuff around. Just keep it just the way it is, and then it works out perfectly. Okay? So if you need to turn your paper, turn your paper. All right? Left side's over here. This is the top, this is the bottom. So that becomes the numerator, that becomes the denominator. 4.9 over x. Okay? Since this is the right side, this is the top, this is the bottom. This is the numerator, this is the denominator. So 4.5 over 2.6. Okay, you can see it sets up that beautiful proportion. And you guys all know how to solve proportions. I like my variable on the left, so I go this way first. X times 4.5. And then cross product this way, 4.9 times 2.6. So this is 4.5x on the left. And then punch that in the calculator. I got 12.74. And then the inverse operation of multiplying by 4.5 is dividing by 4.5. And I had to approximate because it gave me a bunch of numbers all across the calculator. So I switched from a regular equal sign to that little wavy equal sign because I'm going to round to 2.8. And this one was in inches. Okay. Any questions on example 2?